In this video, I'm going to talk about process death on Android. So for those of you who don't know anything about process death, this is a problem that is probably plaguing your applications and you don't even know it. I actually didn't even know about it in one of my more recent courses that I made, the Powerful Android Apps with Jetpack Architecture course, because I didn't know how to test for process death. So in this video, I'm going to be showing you, I'm going to be talking about what process death is, how it happens in your application, how you can test for it, and then how you can build your apps in such a way to handle process death and make sure that your users get the best experience possible and you don't have kind of odd behavior, which it was the case with one of my applications, probably with more of my applications. So first of all, for those of you who don't know what process death is, maybe you've never even heard this term process before, what does that mean? So the way Android apps work is when you fire up an application. So if I was just to grab my phone and start up any application, Instagram, email, anything, it fires up a new Linux process. So for those of you who didn't know, the phone is actually running on a Linux operating system. When an application launches, it starts a process, a new Linux process, where that application lives. So every application has its own Linux process that it gets started in. So what can happen is, say I'm on an app, say I'm browsing Instagram, I'm on my email, whatever. So suddenly I send Instagram to the background. I go to YouTube, I start watching some videos. Maybe I open up a game that's very demanding on the RAM of the device. Then I decided to go back to Instagram later on. That could cause problems. That could cause something called process death. Because what happens is there's only a finite amount of RAM on your device. If you have an application that you send to the background, you start doing something else, something very demanding, what the Android system will do is it will look for applications that don't have a very high priority, aka they're in the background, and it will start cleaning them up. It will start killing processes to free up memory. And nobody knows the algorithm that the Android system has built into it to determine what process goes and what process stays. There's ways to give your applications a high priority over others, but that's not recommended. If you read the Android documentation, it actually recommends not to do that because you're trying to basically cheat the system. You're trying to tell the Android system, hey, don't get rid of my application because it's more important, even though it should be no more important than any other application on the phone. So that's processes. That's how they work on the device. That's how low memory conditions can trigger process death. And now let's talk about what that can do to your app. So what that does to the user experience. Okay, so let me show you a classic case of process death causing a problem in an application. And I'm also going to show you how to test it, how to trigger process death in the application. So here I have the Open API Android app, the one that I built in the Powerful Android Apps course. It's on my website, by the way. There'll be a link in the description to that course. In that course, I teach you things like MVI architecture, repository pattern, retrofit, Dagger 2, room persistence library, all this stuff. The key thing to notice there that I said is MVI architecture. MVI architecture uses ViewModels. So if you're like me, you thought that ViewModels like configuration changes. So if I did a configuration change, notice the app is in the same state, the data is still there, everything works perfectly. If I click a blog, that's all still there. I can rotate back and everything's still good. So if you're like me, you might think that ViewModels handle this the same way, this configuration change thing, the same way as they do process death. So it's not true, and I'm going to show you what happens when I force process death on this application. So what I'm going to do is I'm going to go over to the account section here. Notice that there's some account information. Now I'm going to send the app to the background. So I'm trying to simulate what a process death kind of state, how that would happen. So the app's in the background. Now I'm going to open up Android Studio, and I'm going to kill the process. So I'm going to go down here. I have the logcat selected. Go to this little arrow and click this stop button. And then I'm going to minimize Android Studio because I don't need it anymore. And now I'm going to relaunch the app. So this app is Open API, this one down here. Now watch what happens to the application. It completely breaks. So look, there's no more email, there's no more username. If I go back to the home tab, there's no more information here. It actually crashes. So your app might crash, it might not. This is actually a null pointer that's causing it to crash. The point that I'm trying to make here is that it exhibits strange behavior, and this is definitely going to piss off your user. And it might have gone unnoticed because unless the process dies under, high memory usage conditions, you would never know that this is going to happen to your app. So right now, I actually want to give a shout out to the guy who kind of let me know about this process death issue, because I didn't know about it. I didn't know how to test for it. I knew that if you sent an app to the background and came back after like 30 minutes or something, it might kind of act strangely, and then you just restart it. But really, that was process death that was happening. So if you go to the Open API Android app, this GitHub repository for the app that I just showed you, and you go to issues that have been solved, this is the one that I'm talking about right here. So crash when selecting Home tab. So shout out to this guy right here. I don't know how to pronounce your name. Oh, your name is Gabor? I don't know. I'm sorry if I mispronounce your name, but he let me know about this process death issue, and he kind of gave me steps to reproduce it, which were really helpful. And then I went along to solving this problem, and now here I am making a video about it. So shout out to Gabor. I believe he has Twitter too. You can probably find him on Twitter. So search this name on Twitter, and you'll probably find him and follow him and say, hey, thanks. Mitch says thanks for pointing out that issue. So that is process death. That's how it might be affecting your applications. And if you've never heard of it, I guarantee it is affecting your applications. So now what we're going to do is we're going to do a code demo, and I'm going to show you how you can resolve this process death issue so that when your application comes back after process death, it's going to behave exactly the same as if it did a configuration change or something. So making sure that the user gets the best experience possible. All right, so on the screen now I have the demo application that we're going to be working on in this video. It's quite different than the one I was just showing you, but it'll be fine. It'll be just enough that it'll have just enough things that we can exhibit this process death issue, and then I'll show you how to solve it. So the first screen that you see when the application opens is just a recycler view. If I was to click on one of these, it takes me to a detail fragment with the title of that blog post, an image, and then a description. So it is also leaking memory, which I forgot to fix. So I'll fix that in this video too. But so if I go back, it just takes me back to the recycler view. No big deal. It is actually querying a real API. So if I'll show you the data set that it queries. It's actually querying a data set from OpenAPI/placeholder/blogs. So this is where it's getting the data from. It's just a list of blog posts. They have a primary key, a title, a body, an image, and then a category. So that's all that's showing here. You can see they have a title, an image. There's a body, which is the description. Pretty straightforward, pretty simple stuff. So right now, if I was to trigger a process death, so if I send this to the background, I'm going to open up Android Studio, and let's go to the logcat and then kill the process by clicking the red square. Now I'm going to relaunch the app. So I'll minimize this again, go to relaunch this app, and you'll see that, boom, we lose the data. We lose the data because when the process dies, the data in the view model also goes bye-bye. So that's the problem that we have to solve here. All right, so where can you get this code? Because you need a starting point for this. There'll be a link in the description of this video, but this is the repository right here, MVI example. I suggest just cloning it. So go to clone or download, copy the link, go to Android Studio, and then just go to File, go to New, check out from version control, Git, and then paste that link in there and clone the repository. Once you have the repository open, you'll be looking at exactly what I'm looking at right now, but you'll want to select the correct branch. So this project is actually part of my MVI introduction course, but I created a couple branches for these examples. So the branch that you want to check out is the process death start branch. So you can see down here I have the branch process death start selected. That's this one right here. So you just want to click on it, click checkout. I already have it checked out, but you can see that if you click, there's a checkout option. You just want to do that for process death start. Check out that branch, and you'll be looking at exactly what I'm looking at. And then after we're done, so once we're finished this video, the branch that for the completed version of this video will be process death fix. So if you want to see the end result, just click checkout, and you can take a look at how I resolved the process death issue. So now let's get started with solving this problem. Okay, so as I said, this source code is using MVI architecture. So basically, there's one activity here. There's two fragments. I'll actually bring the app on the screen as I go through this. There's one activity, main activity, and there's two fragments, main fragment and detail fragment. This is main fragment in view here, just has a recycler view. If I click on one of these blog posts, it takes me to detail fragment. So that's detail fragment right here. The fragment factory is just for creating the fragments. The recycler view adapters for obviously the recycler view, and then we have the view model, and we have the states. So we have main view state, which just holds the list of blog posts, and then the blog post for the detail fragment, and then the state events. So there's just one state event that's for getting the list of blogs from the API. All of this is you don't need to know MVI architecture to benefit from this video. I just wanted to kind of outline that. Because the fix is not related to MVI or MVVM, although it is related to using view models. So remember, the problem here is in the application, when the process dies, all the data in the view model is lost. So if you're using view models in your application, you will benefit from the thing that I'm going to show you right now. And also you'll see right here that it's leaking memory. And the reason it's leaking memory is because inside of main fragment, I forgot to enter on destroy view and to nullify the adapter. So recycler, main recycler view adapter dot adapter equals null when the view is destroyed. You need to do that to free up the resources, or else you get memory leaks. So I'm pretty sure that's why it's leaking memory, and I forgot to add that. So anyway, now let's work on fixing the process death issue. So first we'll fix it in main fragment. So I'm going to open up main fragment. I'm going to minimize this to give me some more room, and we will resolve this problem. So the problem here is, as I said, when the process dies, all of the data in the view model also is destroyed. So if I open up main view model, which is the view model that's shared between main fragments and detail fragment, we have the state events, which are for triggering events. Again, if you don't understand how this is working, it doesn't matter. All that matters is that you understand that this mutable live data inside of the view model, we lose that during process death. So no matter what architecture you're using, if you're using view models and you have mutable live data, mediator live data, any kind of live data in your view model, that data is going to be gone when the process dies, and that is the problem. That's what we have to solve. So the data is saved inside of this view state. You can see that it holds a main view state object. So we need to save the data that's being displayed in the view. In the detail fragment, that's just a blog post. That's what's being displayed. In the main fragments, it's a list of blog posts. So that's the data that we need to save when the process dies. So how do we do that? Well, in main fragment, it actually stores a list of blog posts, as I said. So normally what you would do is you would insert the onSaveInstanceState function. So I'm pressing Control-O. I'm going to onSaveInstanceState. And then I would do, outstate.parsable I would say this is the blog list. And I would do ViewModel.viewState.value. And then I would just get the blog posts. So that's a list of blog posts. And then just put that as a parsable array list. So currently this is giving me a warning saying that I can't attach this to the bundle because it's not parcelable. And that's because the blog post object is not parcelable. So let's just go into the model class here, go into the blog post, and I'm just going to annotate this with @parcelize and then implement parseable here. So add parseable supertype. So now this blog post object is parcelable, and this error should go away, other than a question mark that I need to add there to make sure that this is not null. So as I was saying, normally what you would do is just this straightforward. You would save the blog list to the instance state, and then in the onCreate method, so I'll insert onCreate, so pressing Control-O, getting onCreate. Now I would just check for that. So I would say, saved instance state. If that is not null, I can get the in state that's coming in from the bundle, if I could type. And then I would check, for the type, so in state, check for that key, the blog list key. This is going to be as a, I need to close that off, as a list of blog post objects. So I'll do array list of blog posts, and that could be null, so I'll add a question mark. And then I would do, if that value is not null, then I have a blog list that's coming in, and then I would just set that to the view model. So I would do ViewModel dot set blog list data. and then set that to the blog list. Normally, if you weren't saving a list of data, that's what you would do. You would just, if it's a single object, like the case with detail fragments, this right here, just saving a single blog post, basically a small piece of data, then this is fine. You save it to the instance state, and then in onCreate, you restore it. So the problem here is because we're saving a list of data. And if you look at the Android documentation, they actually recommend that if you are saving a list of data, see, they don't really give you a definitive answer in the documentation. They say, like, if you're saving a large amount of data, what does a large amount of data mean? So, but, chances are a list could potentially be a large amount of data, because in this app, there's a couple blog posts, but in a real app, you could have 100 or 1,000 or whatever. So never saving a list of data to the saved instance state is probably a good idea. So what do you do instead? Well, normally what you would do, like in a real application, you wouldn't just have a list here. You would have like in the Open API app, for example. Let me bring it open on the screen. Here we have like a list. We can search for stuff. Like if I search for Kotlin, I get Kotlin blog posts. The point here is that there's a search view, and then the list reflects what the search is. So also, these blog posts are cached. So in this app, in a real app, you would also have caching. So if I turn it on airplane mode and I refresh this, hey, look, it's still here, and I can still do searches because it's searching the cache. It's not just searching the network. So in that scenario, in a real app, what you would do is you would save the search query. So I would do like, blog search query, and I would save that string. I should put this down here. I would save it like as a string, whatever that search query was, if it was Kotlin, and then obviously this would be put string, and then in the onCreate function, I would get the search query. I would read the search query and then query the cache immediately, and then that way the recycler view would be showing exactly what they were seeing, and I didn't do what the documentation says not to do, and I didn't store a big list of data to the bundle. So like I said, in a regular situation, that is what you would do, but this is just an example. So in this case, I'm going to do what they're telling me not to do. I'm going to save that list of data to the bundle. But again, I want to make sure that you understand that you should not do that in a real application. You should save the query. Then once the onCreate function is called, use that query to search the cache and reset your list. But just for this demo, I'm going to leave it as it is, the incorrect way, because I'm going to show you that this does in fact solve the process death issue. So one more issue with this regarding ViewModels is now inside of here in the onCreate function, onCreate is called before onViewCreated inside of the fragment lifecycle. So here we have the ViewModel being created after it's being called right here. So this would obviously cause a null pointer. So what we need to do is take this ViewModel and initialize it inside of the onCreate function. And now actually, because of this process death thing that I've encountered, I'm probably going to be initializing my ViewModels inside of onCreate from now on because of this specific issue. I always used to do it just in onViewCreated or whatever. It didn't really matter. But because of the process death issue, if you're using ViewModels, you should probably be initializing your ViewModel in onCreate. And then once the state is restored, like we're doing right here, you can then set that data to the ViewModel so that if the process dies, it's restored and the ViewModel's data is also restored. All right, so that fixes our main fragment. Now we want to fix our detail fragment. So this one's going to be pretty much the same. I'm going to go into detail fragment. We're going to do the same sort of thing. I'm going to insert on create. So Control O, then inserting on create. First of all, I'm going to take my ViewModel initialization. I'm going to paste it inside of onCreate because that's where we should be doing that now. And then inside of, actually, I'm going to go to main fragment and copy a bunch of this. So I'm going to copy the save instance state function, and I'm going to copy the onCreate function too. I'm copying it all. It's all going to be the same. So I'm going to go to detail fragment, and I'm going to paste over this. And now we just need to change a few things. So this is not a blog list. It's just a blog post. Obviously, this is no longer an array list because it's not a list. This is just a blog post object. This is a blog post. And then here I'm setting the blog post to the blog post. Then the instance state being saved, saving the blog post. We're putting parcelable, not parcelable array list. And I want to get the blog post, not the blog posts, not the list of blog posts. So just kind of quickly going over this, initializing the ViewModel. If there's a saved instance state, we are setting that to the view model right after. And then the onSaveInstanceState will save that blog post to the out state. So I believe that that should be it. So let's run it. I'm going to press Shift F10 to run the application. I'm going to bring it on the screen here, and we're going to test configuration changes. We're going to test process death and just make sure that everything is now working correctly. Looks like I forgot to turn airplane mode off. So let me just turn that off, and I will rerun the app again. So Shift F10 again, because this app is not caching data, unlike the Open API app, which I showed you earlier. All right, so here we have the app launching. There's the fake loading animation in the app. There's the data, cool. Now let's scroll down to the very bottom of the list. We're gonna click on the blog post. So here's the detail fragments. I'm gonna test configuration changes just because. So cool, that works. Yep, that's all fine. Let's go back, and we'll also test configuration changes in the list. So notice that the position of the list is maintained upon configuration change. I can change back, position of the list is good. All that stuff is great. That's all being handled by the view model, because remember, it only will get rid of the data in the event of the process death. Configuration change is fine. So now let's trigger the process death. So I'm going to send the app to the background. I'm going to go down here to the logcat, go over here. If you want, you can actually pull this up, and that gives you more kind of room here. Usually I have it down, and then I just go kind of hover over here and click the stop button. So that will now kill the process. Process is toast. Goodbye, process. Now I'm going to reopen the application. So there's the app right there. And now notice it's fine. Everything is good. So even though the process died, a new process started, everything's good inside that fragment. If I go back, even the list position is maintained. So we have the same data here, and also the list position is maintained, just as if we did a configuration change, so everything is working correctly. Now, before I let you go, I want to go over this again, because I know people are going to say something about this. Inside of main fragment here, I am saving a list of blog posts to the saved instance state, to the bundle. You shouldn't do this. In a real application, you should save the search query, whatever query you used to get that list of data. Unless it's a small list, like a small static list, then that's probably fine. I would say, 10, 20 entries, that's fine. But in an app that could potentially query 50, 100, 500, 1,000 unlimited items for the list, definitely do not save the list to the bundle. In that case, you want to save the string, the raw search query itself. Then when the app is restored, when onCreate is called, you want to get that search query, and you want to search your database cache. If you don't know how to build a database cache, that's what you need to figure out how to do first, because that's your first problem. Then worry about the process death. If you need to know how to build database caches and you've never done that before, go to codingwithmitch.com. Just scroll down on the homepage. I have the local database caching with the REST API course. I also have the powerful Android apps with Jetpack architecture course. This is by far the best one. I show you everything in this one. We got Kotlin, we got MVI architecture, Dagger, navigation components. So that means how to navigate with fragments the new way using the navigation graphs. We've got the room persistence library and building database cache, as I said. So all of that stuff is being cached. So that's actually the app that I had open here for a few seconds when I was doing for a few minutes when I was doing the demo originally. That's this app right here. You can search blog posts, you can log in, you can log out. So I can go to account, I can log out, I can then log in with that email, I can register. And all of this interacts with a real REST API, a real server that I built for you guys. I'm gonna type my password here, I'm gonna pause the video. So there it is, logging in after typing my password, and you can see I have access to the application. Again, if you're curious, this uses a real server, openapi.xyz. That is what this is interacting with. See, does that look familiar? We have this kind of picture here. If I scroll down, I got the Lord of the Rings picture there. I got the Batman picture. All these are blog posts that are being pulled from this actual server. So if you're curious, check out that course here on my website. So what was I talking about? Now I lost my train of thought. No, I think that's it. That's all I wanted to go over. So now you know how to handle process death in your applications. I'll actually also give you a parting gift. If you want to read more about process death in the Android documentation, here's a couple links. AndroidDeveloper.com, guide, components, activities, activity lifecycle, and you can scroll down. There's some charts about processes being killed. This chart I really like. So it's in topic, libraries, architecture, saving states. This is a great little chart. So it says here, you know, if you have the view model, where's the data stored in the memory? Does it survive configuration change? Yes. Does it survive process death? No. Does it survive activity being completed? No. So it gives you more information about this kind of stuff. Saved instance state, which is what we were just working with. Notice, yes, it does survive the process death. That's great. Persistent storage, which is like SQLite, room persistence library, all that kind of stuff. And then one last guide here. So guide, components, activities, process lifecycle. You can read more about processes and how they work in Android and the application lifecycle. So that's going to be it for this video. Hopefully you liked it. If you did, leave a like. If you don't, leave a like anyway. If it helped you in some way, or if you have any questions about process death or other ways you can handle it, just any kind of confusion at all, leave a comment below, and I will try to respond, try to give you a good answer. But also, you should know that there's a lot of different ways you can handle this process death issue. I've only showed you one of them. There's certain libraries out there that can handle it. You could save it to the SQLite local persistence, local database if you wanted to, instead of the saved instance state. There's actually a state handler class that's available to ViewModels now. So if I go state handler and search Android state handler, that is this link right here will probably teach you about it. So there's a optional, instead of saving the state in the fragment or in the activity, you can save it in the view model. The reason why I didn't do that in this video is because it causes problems if you're using Dagger, and I like to use Dagger. It doesn't cause problems, but it's very difficult to use. There's a lot of things you got to do. It's kind of a pain in the ass. So anyway, you can explore that if you want, but I'm going to stop talking because I've been talking too much. I'll see you in the next video.